moment at what I have in my hands right now just now. Okay, so you imagine this is your beaker. Alright, so you're going to conduct an experiment. Alright, okay, between acid. Over here we have acid, which is hydrochloric acid. Right, hydrochloric acid. Okay, and then over here you have zinc. Right, you have zinc. Okay, in the form of powder. Right, but I show you the molecules of that particular substance, right, over here. Okay, and now I ask you to mix up, right, these two substances into a beaker, right? Okay, so this here, okay, you put this here over here, and then you take your zinc powder and then you mix it over here. Okay, and then you mix. First thing first, what will happen? What will happen for these atoms, for this substance? It will collide. Another one? Other than collide, it will produce product, right? Yeah. Basically, what you've done for the experiment is you want to get a product, right? Yeah. So what kind of product are you to produce? Zinc chloride and hydrogen. Yes, right? So before that they becomes a product, okay? That's what I see just now. They have the collision, right? So this is what we're going to learn in collision theory. But okay, let's take a look how the collision would happen. Right, so for this one, okay, how would the collision happen? Between what and what? Which atom? Zinc atom and hydrochloric acid. Okay, which part of hydrochloric acid will collide with zinc atom? Hydrogen ion. Good job. Right. So the one that will produce a collision, okay, is between the hydrogen ions and also zinc atom. Right. So they will collide together. But there are some factors that might affect this collision. Correct? How many factors that we have learned before? Can you take it? Concentration, good job. Patricia? Temperature, okay. Adi? Size of what? Size of surface area? No. Size of what, Daniel? Reactor. Okay, but good try, okay. Okay, you okay, how about the last one? Presence of catalyst. So these four factors, okay, will impact the collision. Right? So do you guys understand? Right. So now let's move on, right, to what you need to know, right, for collision theory. Right? So first one, you need to know how to describe the collision theory, right? By the end of our lesson today, you need to be able to describe the collision theory. And then you need to explain the activation energy using some example. And the last one is interpret and chemical reactions, alright, there will be a collision, right? So each reactant particles will collide with each other and produce a product, right? So when they collide with each other, okay, they will produce a kinetic energy, right? The transfer of energy in the form of kinetic energy, right? So when the kinetic energy, right, of each particles, when they collide, okay, they will constantly changing. So when they are changing, they are changes, right? So that's why you can calculate the rate of reaction based on time, right? So you have the amount of times, and then the energy is changes, right? So that's why you can calculate the rate of reactions per unit time, right? So that's why when collision occurs, obviously you will calculate the rate of reactions. Okay, so this is basically, alright, what collision theory is. Alright, collision theory says that reactant particles must collide with one another for reactions to occur. Right, and the rate of reaction will depend on the frequency of effective collision. Right, so what the differences between a collision and an effective collision? What is the differences? What do you guys think? You guys have any idea what is the differences between a collision and an effective collision? What is the differences? Nah, Dania. Alright, correct, right? So you got right. Okay, so actually collision, right? The particles will collide. But we don't know yet whether the particles will produce a product or not. But when we talk about effective collision, the terms also say that effective. That means your collision will produce a product, right? So when you have a collision and then it will produce a product, so that's what we call as effective collision. But when the reactants just collide with each other, but they doesn't produce any product, so that's what we call as a collision, right? So there might be an effective collision and there might be an ineffective collision because the reactant particles must have energy equals to or more than activation energy and collide in the correct orientation. So this is the requirement, alright, for reactant particles to become a product. Okay? So over here, right? See, you can see over here, right? The horses over here. Okay? See, this is the energy of activation energy, right? So you have a fence over there, right? There's a fence over there. So this is the maximum energy that each particles need to achieve in order to become a product, right? So that's why the horse, when they want to pass through the fence, okay, they need to jump. And the horse can jump when the rider did something to the horse, right? I don't know how they do, but they did something lah. They teach the horses when they see the fence, and then they do like slapping the horse. I don't know what they do, but they did something so that the horses can jump over the fence. So that's what, okay, happens to our chemical reaction also. Okay, when you put your reactant, okay, in a chemical reaction, okay, and then you put temperature, you increase the temperature. So the temperature is like the rider over there, right? It signals, right, the reactions to become higher. It jumps over more towards the activation energy. Jump over the fence. So the fence is activation energy. The horse is your reactant particles. The rider actually your factors that affect your rate of reaction. So that is the analogy of how collision theory works. You understand? Yeah?
Good.
Alright, okay, so now let's move on to the collision theory with the orientation that is correct. So before this, on our previous class, you already learned on how to answer the technique, right? The technique of collision theory. Okay, so this is basically, okay, what is the principle of collision theory say, right? So when you collide, you need to collide in the correct orientation. Okay, so you see over here the green one and the pink one, right? They will meet up, and then they collide in the correct orientation, and they produce a product. You can see over here, but over here you can see if the collision is effective. No, right? Because there is no correct orientation. They collide with wrong orientation. So that's why they cannot produce a product. But is there any collision over here? Yes. That is collision, but it's not effective collision. Right? So that's why when you learn on the previous class regarding the collision theory, when you answer the technique, okay, some of it might have a frequency of collision, but some of it doesn't have frequency of collision. They will direct to the frequency of effective collision, because, right, that factors really impact, right, the production of product, right? It will directly give you the product. So that's why we don't need to tell them in terms of frequency of collision, right? So can we do some activities? Yes. Right. So over here I have 5 envelopes. So I need each one of representative from the group to come here and pick your envelope. 5, 4, 3, 2. Alright, so you can open up your envelope and see what the tasks have been given to you. Okay, so work in a group. Okay, so try to answer the questions that have been given to you.
Girl, where you at? 해가 떠서질 때까지 나 계속 불안해. By the end of the day 미치겠어 miss you. 눈부신 아직 내겐 영원 같은 waiting. 격한 이 fate 너를 그리는 daydream. 널 원하면 원할 수 I feel so lovely. 시작되는 망상들은 끝까지 날 push me. 지옥 같은 시간 내 난 깨달아. 낮 됐건 밤이 됐건 의심 없이 I love you. Ain't no doubt, no 나의 love, no worries. 난 괜찮아. 널 원해. 괴롭지만 날 태워 증명해 baby no doubt, no exit. 갈증에 난 본능해. 원해 너만 널 원해. 괴롭지만 날 태워 증명해 baby no doubt.
Alright, okay, so time's up for everyone. Alright, so after this, okay, what I want you guys to do is, alright, so you guys already answered that in your books, right? In your module, right? So I want you guys to scan, right, the answer and submit it to me so that I can see, okay, your understanding, right? But I will pick one group, right, that will need to present, okay, in front, okay, that need to present in front, okay, to see whether our class today have achieved the objective or not, right? Okay, okay, right. So I'm going to do the wheel of names. Okay, so let's take a look. Okay, group Dania. Alright, okay, so Dania and the group can come to the front and then tell us your questions and answer for that particular. And others can open to the page 182 on your module. Alright, and try to listen. Okay, try to listen and understand what have been presented by your friend? Okay, let us check together. So they you need to give your names and then tell which question we got. Okay, go. Where the question? Can you briefly explain what the experiment is all about first? Because they don't know, because it's your question. So explain a little bit, briefly. Which factor involved? Size of reactor. Okay, next.
And for experiment B, they have open to surface solution, which is presence of particles.
Alright.
So if state the meaning of rate of action for this experiment, mean is the change in the unity of vector or product to unit time.
Okay, so now you read the question carefully. So because they state the meaning of the rate of reaction for this experiment, so which is very specific. So what have Akil told us just now, is it specific? Is it specific? No, because they just tell us about the reactants or product. So but the question asks you for this experiment, so you need to identify which is the reactant, which is the product, and you need to explain which one. Right, so you're going to see about the reactant, so the changes in the zinc and hydrochloric acid per unit time. Okay, so we have to be specific lah. If that's okay, so next one, next question.
This question So as example, the highest temperature is 73 because it takes to achieve the product.
To achieve the product, what product that you mentioned just now for the 30 seconds?
Hydrogen gas.
Hydrogen gas, right? So it takes 30 seconds to get how many volume of hydrogen gas? They mentioned 40 centimeter cubic, right? So 40 centimeter cubic, alright, it only takes 30 seconds. So that's why experiment 3 has the highest rate of reaction. Okay, understand? Alright, okay, so for the calculation, you can take the whiteboard marker over there. Here. You can show your working. And show. STB experiment 3. Okay, so the average rate of reactions you got how many? 1.333 centimeter cubic per second. Remember, they need to have 3 significant figures, right? And don't forget about the unit. Alright, so the next question. Alright, correct. Okay, chemical equation. Write down in front. Okay, right. So you have balanced chemical equation zinc plus hydrochloric acid. You got zinc chloride and hydrogen gas. Okay, correct. Okay. Right. So the last question regarding compare the rate of reaction. Okay, so this is very important. Take note. Okay. You got that first point? Yeah. Compare first the rate of reaction between experiment 2 and experiment 1. Right? Because experiment 2 has higher rate of reaction compared to experiment 1. Okay. The second point is explain your factor, right? You tell the factor which is the size, right, of the reactor, and then you explain it using total surface area exposed to collision, right? It's higher in experiment 1 compared to experiment 2. Can you use higher for total surface area? Larger. Okay, bigger pun tak boleh. Bigger only for size. Okay, total surface area is larger, right? So, we need to correct it, not higher. Okay, it's larger. Right? After that, okay, and then you compare the frequency of collision, right? Okay, after that, the last point. Alright, okay, after that, you compare the frequency of effective collision, right? So, do you guys understand? Okay, you guys get full mark for this question? Okay, so give a big hand to the collision theory. Right, so before we end our class today, can I have like three of you, actually representative of you, like to tell me, okay, what did you guys learn for today? So anybody here? Anybody here? What you learn today? Yeah. Alright, so today Agalia said she learned about how to differentiate between effective collision and collision. Right, good job. Right. Okay. The other 2%. What you have learned today? What you have learned today? Okay, Amber. Alright, so collision can occur when they are in correct orientation. Okay, good job, Amber. Alright, so the last one, last percent. Anyone want to tell me what you have learned for today, what you have did? Okay, Patricia. Alright, correct. Rate of reaction is depend on rate frequency of collision. Okay. Alright. So just now I already told you guys, right, regarding the things that you have to know, you have to achieve at the end of our class today. So did you guys manage to achieve all of that? Yes. Can you guys describe the collision theory? Yes. Can you guys interpret the profile diagram regarding collision theory? Yes. Correct. And can you guys give example of collision theory using endothermic reaction or exothermic reaction? Yes. Right. So basically that's our class for today. So you guys have any questions before we end our class? Everything clear to you guys?